Hello everyone, welcome to my channel Tales of Chemistry. Today's topic is Class 12 ISC Organic Compounds Containing Nitrogen. There are two organic compounds of nitrogen that we need to study here. One is amines and the other one is diazonium salts, diazonium chloride. Let us begin with amines. So, before we learn the preparation and properties, it will be better if we get familiar with the types of amines. The first one is a primary amine. Primary amines are written like RNH2, or it can also be written as ARNH2, whereas R represents alkyl group and AR represents aryl group, aromatic amine. Specific examples, if you want to look at, one is CH3NH2. Now, how will we name this? There's only one carbon. Since there is only one carbon, meth is the root word. And saturation, to represent saturation, we write AN only. Then to represent the presence of NH2, word amine has to be written. So this example, CH3NH2 is now called methanamine. Then what will be its common name? Let's see. Methyl. Methyl is for CH3. Methyl amine. Common name is methyl amine. Now, moving on with the next example. CH3, CH2, NH2. What is this? There are two carbons. Therefore, the root word will be ether. Saturation, that means single bond between carbons. To represent that, an is written. AN alone, not ANE, just AN. To represent NH2, amine. So, name of the second example becomes ethanamine, or in common system, it is ethyl amine. Ethanamine or ethyl amine. Okay, now moving on. Aromatic amines are also there. ARNH2. Now, as per our ISC syllabus, we just need to learn about this C6H5NH2 or the benzene ring, the phenyl group or the benzene ring connected to NH2. Now, this is called aniline. Now, though aniline is the common name, more than the IUPAC name, we are using the common name itself. By the way, what can be or what will be its IUPAC name? Benzene amine. IUPAC name is benzene amine, but we are using the word aniline more frequently than benzene amine. Second type of amine is secondary amine. Secondary amine, which is written as 2 degree, secondary amine. In this, two alkyl groups are attached to NH. What did I say previously under primary amines? Under primary amines, it was one alkyl group and that was connected to a NH2. One alkyl group connected to NH2. Whereas in secondary amines, two alkyl groups are there. And these two alkyl groups are connected to NH. Two alkyl groups are connected to NH. Now, look at the examples. or NHR, which can also be written as R2NH. R NHR or R2NH. Let's look at some important examples. So I'm not giving you all examples. Okay, our intention here is not to learn nomenclature, but we are just learning the names of those amines which we will need. Probably, if you have not paid attention in your 11th grade, you may not be aware of this name. So that is the only idea here. Before we get into the lesson, let us be familiar with the names of those common amines that we will use in this lesson. So, the first example has CH3 group 2 times. Two CH3 groups are there on either side of NH. Now, in the IUPAC system, point number 1 is look whether it is NH2, NH, or just N. So this is NH. Once you identify that, look for the longest carbon chain. Okay, alongside that NH, where is the longest carbon chain? Fortunately, here both carbon chains are identical. It is CH3 on both sides. Therefore, send or connect your NH with any of the alkyl groups. Connect your NH with any of the alkyl groups here. So that becomes the parent, and whatever is excluded now is the substituent. What is the name of the substituent? Methyl. Okay, let's first write the name of the parent. In the parent, whatever is in the box now, how many carbons are there? Just one carbon. So meth, amine. Now look at this point, whether it is NH2, NH, or just N, the word must end with amine. So parent here is methanamine, but we have a methyl group also as the substituent. Where is the methyl group present or connected to? Methyl is connected to the nitrogen. That's why we write here N-methyl methanamine. N-methyl methanamine. Yeah, N stands for nitrogen. Methyl is connected to the nitrogen. N-methyl methanamine. That is the IUPAC name. Now, in the common system, there are two methyl groups. So, dimethyl amine. That is it. Dimethyl amine. Now, moving on to the second example. One side there is CH3, the other side it is CH2, CH3. Right? The CH2, CH3 part can also be condensed and we can write it as C2H5. Doesn't matter. Both are the same. So any which way, IUPAC is suggesting that whichever is the longest carbon chain, that must carry NH. So CH2CH3 goes with the NH and that becomes the parent. Now, what is the name of the parent? In the parent, the IUPAC name will be, two carbons are there, therefore, amine. So I'm repeating once again that whether it is NH2 or NH, the name is amine itself. So in IUPAC, the parent's name is ethanamine. But what do I have apart from that red box? I have a CH3. Where is that CH3 present? Again, it is on the nitrogen. CH3 is connected to the nitrogen. So this is once again N-methyl ethanamine, N-methyl ethanamine. That is IUPAC. Now, in the common system, just name the alkyl groups in alphabetic order. Ethyl, methyl, amine. Ethyl, methyl, amine. Now, instead of this R on any one side, it can be an aryl group. On both the sides also, it can be aryl. So I have already told you, we are not learning the names of all the amines. Instead, we are just learning those amines that we need to know as per the ISA syllabus. Last one example under secondary amine. CH3, CH2, NH, CH2, CH3. So both the sides of NH2, you have the same group. So send NH with or connect NH with any of the alkyl groups. Connect NH with any of the alkyl groups because both are identical, and that becomes the parent. Outside the parent, you have CH3, CH2, which is ethyl. Ethyl is connected to the nitrogen. So N-ethyl, and the rest is ethanamine, N-ethyl ethanamine. So minimum examples under secondary amines also we have covered now. Moving on, tertiary amines. In tertiary amines, if three alkyl groups are connected to nitrogen, then it is called a tertiary amine. If two alkyl groups are connected to a NH, it was secondary. When three alkyl groups are connected to N, it is a tertiary amine. It is a tertiary amine. Let's learn minimum examples. First one, N is connected to three methyl groups. So as we know, one of the groups, or precisely the longest carbon chain, should contain the N. Now here all the three carbon chains are identical. They're just methyl groups. So I'm just connecting N with one of the methyl groups, and this is called methanamine. This requires no explanation now. Even if it is a N, we call it amine itself. Okay. Now, what more are there? On the nitrogen, there are two methyl groups, two dimethyl. Where are those methyls connected? Individually, they are connected to the same nitrogen. So this happens to be N, N dimethyl. N, N dimethyl methanamine. That is the IUPAC name, and the common name of this example will be trimethylamine. Trimethylamine. We can stop learning the common names hereafter, not required. Then last one example under tertiary amine. Okay. No explanation needed, I guess. CH2, CH3 is the longest chain. Connect N with that. So it is ethanamine. There are two methyl groups. So dimethyl, both are connected to the nitrogen itself. So NN dimethyl ethanamine. So the basic minimum nomenclature knowledge that we need to learn this chapter, we have got it now. Let's learn the next point. Amines are actually called the derivatives of ammonia. Amines are called the derivatives of ammonia. Why are they called the derivatives? What is a derivative? Something that has derived from. So here, by calling amines the derivatives of ammonia, we understand that these are derived from, okay, these amines are derived from ammonia. Look at the structure of ammonia. Definitely it has a lone pair of electron on nitrogen and 3 NH bonds. But what is a primary amine? You still have a N with a lone pair of electron. You have two hydrogens and there is one R group, RNH2, primary amine. But what is a secondary amine? RNR. So with rest all is same to ammonia, as in one nitrogen with a lone pair. In ammonia, you have three hydrogens. When you remove one hydrogen and replace it with an alkyl group or an aryl group, you get a primary amine. And when you replace two hydrogens of ammonia, you get a by alkyl group, you get secondary amine. Similarly, when you remove all the three hydrogens of ammonia and you replace it with alkyl group, then you are getting tertiary amine. So our lesson here, this particular chapter, begins with the statement that amines are the derivatives of ammonia. And now we know what is the reason. Amines are obtained by replacing the hydrogens of ammonia successively by alkyl groups. Okay, aryl is also possible. I'm repeatedly telling alkyl just based on the required syllabus. So the next topic, which is very important, is preparation of amines. Okay, preparation of amines. So under this preparation of amines, the first one, amines are prepared from nitro compounds by reduction. What are nitro compounds? How do we write them? RNO2. I can even write ARNO2, aryl compounds, okay, like nitrobenzene. So RNO2, this is to be reduced. What is reduction? You can add hydrogen, or removal of oxygen is also reduction. So here what I'm doing is I'm removing oxygen and adding hydrogen. Removing oxygen and adding hydrogen. So RNO2 plus H2. When I add hydrogen, I need a catalyst. What is the catalyst that I can use? I can use metals like nickel, platinum, or palladium as the catalyst. So RNO2, which is a nitroalkane, when treated with hydrogen in presence of a catalyst, the product that I get is RNH2. Now look at this. I have to remove both the oxygens and give back two hydrogens. I removed two oxygens, so I'm giving back two hydrogens. Plus, the oxygen which is removed now will combine with hydrogen, forming H2O. Now see, balancing, technique of balancing. NO2, there are two oxygens that I'm removing. Therefore, two water molecule has to be formed, definitely. Now, how many hydrogens? 2 into 2, 4 plus 2, totally 6 hydrogens. So write 3H2 here. Your equation is balanced. Now, specific examples for this. CH3NO2, which is nitromethane. This will be called nitromethane. Nitromethane is again same way treated with hydrogen in presence of a catalyst. Let me pick one catalyst, okay? I'm picking nickel. So the product here will be CH3NH2 plus 2H2O. See, this is what you will study. Then whatever is in the place of R, here R is CH3. So repeat the first equation, the general equation, replace R by the required alkyl group. Here it is the methyl group, right? So your product here is methanamine. Yeah. Now, another example is C2H5NO2. I can write CH3 single bond, CH2 also, both mean the same. CH3, CH2NO2. This is, okay, nitroethane. Now, instead of writing molecular hydrogen, like in the previous case, I want to take nascent hydrogen. So I took 3 molecules of hydrogen previously. So that 3 molecule is equivalent to 6 atoms of hydrogen. Now, when I write nascent hydrogen, I need something which will provide me with nascent hydrogen. As in, I need a reducing agent. I can take reducing agents like lithium aluminium hydride. I can take tin in dilute hydrochloric acid. I can even take Fe in HCl, hydrochloric acid. Let me write Fe in HCl here. Any one of these can be taken. I have selected Fe in HCl. The product is C2H5NH2 and 2 molecules of water. So once you study the general equation, then the rest becomes easy for you. So here the product is ethanamine. We have already learnt the name, so this is easy to understand. Ethanamine. Now, a slight possibility of one question is there in ISE under give reason. Which among the following reducing agents are preferred and why? So, Fe in HCl is preferred. Fe in hydrochloric acid is preferred. The reason is when Fe in HCl releases nascent hydrogen, the byproduct that you get is FeCl2. Okay, the corresponding chloride. Now, this ferrous chloride will combine with water. Where is water? The byproduct of the reaction. So, FeCl2 and water together, they undergo a chemical process called hydrolysis. And as a result of this hydrolysis, it again produces HCl. FeCl2 with water produces HCl. That HCl can be again used to produce nascent hydrogen from remaining Fe, which means you don't have to use a large amount of hydrochloric acid. You just need minimum hydrochloric acid just to initiate the reaction. The rest of the reaction will happen because of the hydrolysis of ferrous chloride. That is why among all the methods of reduction, Fe in HCl, this reducing agent is preferred. I hope that point is clear. Okay, now the same thing, same reaction can also be written using ArNO2. So let me straight away take an example. C6H5NO2. Yeah, this is nitrobenzene. You're familiar with this 11th standard. Enough and more number of times you have come across this nitrobenzene. So this nitrobenzene, okay, is reduced. So for a change, let me use SN in HCl here, and the result will be, so this will provide us with nascent hydrogen, and we will get C6H5NH2 along with that water molecule. So that's our first method of preparation of amines by reduction of nitro compounds. Nitroalkanes on reduction gives primary amines. It gives primary amines. Okay. So now the second and one of the important method of preparation of amines is Hoffman bromamide degradation reaction. Hoffman bromamide degradation reaction. Now, in this, primary amines are prepared from amides. So, one of the important points to keep in mind here is primary amines are prepared from amides. So now what are amides? Amides are compounds of the type R C double bond O NH2. These are amides. These amides are to be treated with bromine. Hoffman bromamide. Amides are treated with bromine in presence of alkali. Okay, aqueous solution or alcoholic solution of NaOH or KOH can be taken. Now here what happens is, from the amide, you will be removing this CO group. So, the easiest way to understand this is, first of all, remove that CO. What do we have now? RNH2. So I got a primary amine. Where will the CO go? CO will combine with or interact with KOH, and it will give us K2CO3, potassium carbonate, as well as bromine is also interacting with KOH, giving potassium bromide. Along with this, water molecules are also there. So learn this general equation, and you can apply it in any given situation. Say, for example, it is CH3C double bond O NH2 that you are treating with Br2 and with potassium hydroxide on heating. Okay, this KOH can be aqueous solution. It can even be alcoholic solution, as in you can dissolve KOH in water or you can dissolve KOH in alcohol. Now, this CO is what we are removing initially. Therefore, we will be getting CH3NH2 plus potassium carbonate plus potassium bromide plus water. Now, when you learn an equation, okay, learn it completely as in every product has to be mentioned and the equation has to be completely balanced. Otherwise, you will not be getting any marks. Okay, now just to know the name of this product, not product, the reactant substrate. CH3CO. So there are two carbons. So ether, between carbon, single bond, ethan, amide. So this is ethanamide, or in the common system, this is acetamide. Acetamide is treated with bromine and in KOH solution, and the product that you get is methanamine. This name is familiar, methanamine. Now, in ISC, you all know the question can either be explain Hofmann-Bromamide reaction with an appropriate example, or they will ask, what do you get when ethanamide is treated with bromine in presence of an alkali? What do you get when ethanamide is treated with bromine in presence of an alkali? Okay. Now, equation has to be written. Even if they ask, what do you get? Do not just write the name of one product. Yeah, always give the completely balanced equation. Now, moving on, another equally important named reaction is Gabriel phthalimide synthesis. Now, previously for Hofmann-Bromamide degradation, I told you it is for primary amines. Now, Gabriel phthalimide is for primary aliphatic amines. As in, your aniline cannot be prepared by this method. You can just prepare as per syllabus, methanamine or ethanamine, primary aliphatic amines, or any primary aliphatic amine can be prepared, but not aromatic amine. Let's see what is the reaction. Okay, in this, the starting material is called phthalimide. Look at the structure of phthalimide. It has a benzene ring. Okay. C double bond O on adjacent positions, and that is connected to NH. So this is phthalimide. This is the compound called phthalimide. Phthalimide is to be treated with alcoholic solution of potassium hydroxide. Now, look at this. The H, which is on nitrogen, that H, all right, is replaced by K. Or in other words, the H here combines with the OH here to give you a molecule of water, and K will take the position of hydrogen. This K will take the position of hydrogen. So what do you get? You will be getting the phthalimide itself, C double bond O, N, okay, but no H there. Instead, it is a K. Okay, now this will be an ionic bond. N will have a minus charge, K should get a positive charge. Now, that is potassium phthalimide. This is called potassium phthalimide. Potassium phthalimide is then treated with Rx, whichever alkyl group you want to see in your amine. I repeat, whichever R group you want to see in your amine, methyl or ethyl, accordingly take the Rx. Take Rx, select Rx accordingly. Now, this K and X minus, K plus is there, isn't it? And the X minus, that should give us Kx plus, you will be getting your phthalimide now with a slight change. N, and on the place of, on the place of K, now what do you have? R. Okay, so NR will be obtained, which is called, I'll write the name here. This is called N-alkyl, meaning alkyl group is there on the nitrogen. Alkyl group is on nitrogen. N-alkyl phthalimide. This is called N-alkyl phthalimide. N-alkyl phthalimide. We are not done with our reaction. We have not got our final product. Now, in the next step, take the product. That is, I'm repeating the structure of N-alkyl phthalimide once again here. N with R. Okay. Now, this is to be treated with NaOH in water, aqueous solution of NaOH, or in other words, you are hydrolyzing. You are hydrolyzing N-alkyl phthalimide in presence of an alkali. So now what happens is when you hydrolyze, look at this CON bond as well as this CON bond we are breaking. Okay. Now, when we break this, what else is present? NaOH is there, isn't it? With the presence of NaOH only, we are breaking this bond. From NaOH, H will be moving with nitrogen. NaO will be moving with the carbon. Same thing is repeated. NaO will remain with carbon. H will remain with nitrogen, which gives you now C double bond O, the ring with the C double bond O, and ONA connected to each of the carbon. ONA connected to each of the carbon. And then you have RNH2. The R, which is already connected to N, during hydrolysis, your N got in contact with two atoms of hydrogen. So you could prepare your primary amine, that is RNH2. Now, let me explain the same once again with a specific example. So I'm beginning with phthalimide, right? This is the structure of phthalimide. Phthalimide is to be treated with alcoholic potassium hydroxide, and the H and the OH connect together to give us water. For a change now, I'm writing that water as minus H2O. And then I have my phthalimide with its hydrogen replaced by potassium. N, K, and minus charge on N, plus charge on potassium. If you forget to put it, it's absolutely fine, right? Now, after this, we have to treat this potassium phthalimide with the required alkyl halide. Let me take CH3Cl. Now, K plus will go along with Cl minus. So, minus KCl. This means I am removing KCl. Now, what is remaining there? The
benzene ring, your C double bond O remains intact, which is connected to a nitrogen, and that is now connected to the CH3 group, which is N-methyl. N-methyl phthalimide. N-methyl phthalimide. Now, treat this N-methyl phthalimide with solution of sodium hydroxide. Okay, plenty of dilute sodium hydroxide solution. Hydrolysis is the process. Now, what is that you need to break? Both these bonds are broken, and that nitrogen which is on CH3, that nitrogen gets 2 hydrogens from sodium hydroxide, and you have the phthalimide in a different way. Now it's not phthalimide anymore, I'm sorry. You have these 2 groups, yeah, COs, and each of that is connected to a ONA, and this is called the sodium salt of phthalic acid. Sodium salt of phthalic acid, or sodium phthalate. Sodium phthalate. Okay, so we have now completed totally 3 different methods of preparation of amines. That's all for now. Stay tuned for further videos. Thank you.